Hi guys, so what we're going to do today is we're going to use our calculators to learn some more stuff about polynomials. So the first thing we're going to do is we're going to look at regression. So we did regression earlier this year with sinusoidal functions, and you've done regression, I know, with linear functions back in Algebra 1 at least. So what we're going to do now is we're going to look at the other regression modes that we haven't quite seen. We're going to do quadratic, cubic, and quartic regression. So the process here is very similar to what we did back when we had linear regression, things like that. We type in our values into the table. So in this case, my x is my year, my y is my price. It tells you that x equals 0 corresponds to 1980, which means that over here in 1981, that would be an x value of 1. This would be 3, 5, 7, 9, 11, etc. Because that's what it corresponds to. So what we're going to do is we're going to type those values into our calculator. So we're going to go to we're going to go to stat, we're going to go to edit, and then in L1 we're going to type all of our x values, and in L2 we're going to type the corresponding y values. Now I've already typed these in to save some time, but if you want to put yours in, you can pause the video. Once you have them typed in, we're going to make sure our window makes sense. So my biggest x there was a little bit less than 20, so I made my x max 20. I made my y max 40 because my biggest y value was 35.75, so I made sure my window fit. Then I need to make sure my stat plot is actually on. So if you go to second, y equals, stat plot, go to number 1, and just make sure that that is on. And there's some other things you can change there, but for now, everything should look like this. Once that's all done, you can go to your graph and you can look at your scatter plot. Now sometimes from looking at your plot, it becomes very clear which mode you should use. For example, if you were to have those dots kind of go in a pattern that looked something like this, that would be your cubic regression because it looks very similar to the cube parent function. If you were to see one that looked like this, where it's up and up on both ends, but it has kind of that bump in the middle, that would be your quartic regression. But sometimes it's kind of hard to tell just from looking at your picture which mode you should, or which model you should use. There's another way to check to see which one's going to be the most accurate. So what we're going to do is we're going to go to Stat, then we're going to go over to Calc, and we're going to try all three different options here. So the first one I'm going to do is quadreg, that is quadratic regression. So that's going to give us a quadratic equation that best fits those data points there. So I'm going to get to press Enter, I'm going to scroll down to Calculate, and that gives me my regression equation. I plug in A where the A is, plug in B where the B is, and plug in C where the C is. And that's the quadratic model. Now the R squared, that's what helps us see how good our model actually is. The closer that value is to 1, the better it is. So right now it's at 0.985, which is not bad. But we're going to see if the other ones are going to be any better. So let me go ahead and try cubic then. So I'm going to go to Stat, I'm going to go over to Calc, and I'm going to go down to cubic regression. And I'll go down to Calculate, and it's going to give me the cubic equation that best fits that data. And again, if you notice, there's one more letter here because I have an x cubed, an x squared, an x, and a constant. And you would just, again, plug those values in. So for example, if I wanted that equation, it would be y equals 0.003x cubed plus 0.05, we'll call 0.06x squared plus 0.08 x plus 1.4. Alright, then the last one, if you're looking at our regression equation there, or r squared, a little bit better, 0.9858. So let's try the last one. Let's try quartic. I keep going to mode for some reason. So I go over to Calc, and I'm going to do quartreg, which stands for quartic regression. So this is going to give us an equation in the form of x to the 4th power. So I go to Calculate, and if you look here, I have to scroll down because this one goes all the way to e since I'm doing x to the 4th power. And those little dots, I think you guys can figure out what fills in. It would be plus cx squared plus dx, and then e is by itself with no x's. Now my r squared here, this is actually the best model because this gives me an r squared of 0.99. So the model I would actually pick here would be quartic regression. And again, sometimes you can tell just from looking at your stat plot what kind of shape your points are in and which one will make the most sense. So what it tells us to do now is to actually use that model to estimate the average price of the stock in 1990 and in 1996. So what we would do here is we would take our equation. So in this case, my equation would be y equals 0.002 x to the fourth plus, or sorry, minus, it's a negative, minus 0.06 x cubed plus 0.82 x squared minus 3x plus 4.55. And I'm not being too specific here on the rounding. I just want you guys to see kind of this process. We're not going to do a lot of this. So I want you to see just an example of how this works. So what I would do to figure out the price in 1990 is I would plug in a value for x. 1990 would correspond to when x is equal to 10. So I would just plug in 10 for x and find my value. Same thing with 1996, I would plug in 6 for x and see, or 16, I'm sorry, for x to see what I get, and that would be the average in 1996. And that just tells you to look at your, tells you the actual price and just says to see how your estimates kind of compare. But with regression, I just want you guys to see kind of the different options that you have there. We're not going to do a lot with regression. We're going to do a lot more with this next part coming up. So the next thing we're going to look at is our local extrema. Now, local extrema are basically, we call them local because it may not be the actual maximum or minimum on a graph, but in a specific section it is. So for local extrema, there are local minimums and local maximums. So if I have some equation, let's say my equation kind of looks like a cubic function a little bit. Now if you see, there isn't really a maximum to this graph completely, because that graph goes on forever to infinity, and it goes, there's no minimum because that graph goes down forever. But what we can do is find a local minimum and a local maximum by looking at just a certain section of this graph. So for example, if I look at this part of my graph right here, there's a minimum and a maximum value on there. So if you look, this point right here, that top of that curve, that's a local maximum because it's the top of that little curve. Then if you look here, that point there is a local minimum because it's the lowest point on that curve. So the local mins and maxes, I believe your textbook kind of refers to them as turning points, and that's really kind of what's happening. It's the point where your graph turns. So it's the highest of those little peaks are our local maximum, the bottom of those little peaks are our local minimum. Now you guys have seen these kind of when we were drawing our graphs, but we haven't had to evaluate them because we're going to use a calculator in order to do that. Now your graph could have multiples of these turns, but the most it could ever have is whatever the degree is. So the max number of local extrema could possibly be basically n minus 1, which is the degree minus 1. So if you have a third degree polynomial, you won't have more than 2 of these turns. So you couldn't have more than 2 of these. If you have a fourth degree polynomial, you couldn't have more than 3. So let's go ahead and look at a fourth degree polynomial. We're going to look at this one down here, and we're going to go ahead and type that equation into y equals on our calculator. And I'm going to go ahead and turn my stat plot off to make sure I don't have any mistakes here. If you scroll up where it's highlighted and press enter, that will take your stat plot off. So I'm going to do x to the fourth power plus x to the third power minus 6x squared minus 4x plus 12. And my window is going to be a little bit different here. I'm not quite sure where it's going to look like, so I'm going to do zoom 6. That's the standard negative 10 to 10 window. And that'll give us at least a starting point. Alright, so if you look at your window, I can need to move my y values up a little bit. So I'm going to go to my window, and I'm going to make my x min, I'll just make that 0 because I don't really need any of those negatives. I'll make my y max a little bigger, let's go up to 15. This might make our picture a little bit easier to see. Oops, sorry, I did x's instead of y's. Whoops. Long day, guys, I'm sorry. There's negative 10, now it's negative 11. Negative 10 to 10. Let me change my y's like I meant to do originally. I'm sorry, guys. This should be enough for me to actually see my graph. Alright, so now if you guys look at that picture, we have 3 local extrema on this picture. There's 2 local mins and 1 local max, because there's 3 turning points. So if you look, there's two minimums. One is here, and then there's a maximum up there. So in order to find those points, there's a function on our calculator you may have used before. So I'm going to do second calc, and we're going to find the minimum first. So we're going to use number 3 where it says minimum. So what's going to tell me, the first thing it says is left bound. So what I need to do, you guys see your little blinking cursor, I need to move that blinking cursor to the left of my lowest point. Once it's somewhere to the left of it, I press enter. Now it says right bound, so I'm going to move that cursor to the right of my lowest point. And then it says guess, I'm going to press enter one more time. And that gives me my minimum value. It's -2, 4. Now it's good to know where it's located. It's good to know that it's located at -2, 4. But when we're talking about minimums and maximums, we're talking about the heights. So we're really going to focus on here is that y value. So the lowest y value here is 4. So that local min's at 4. It's okay if you want to say it's at the point -2, 4. Just remember our y value is actually the height of it. So now let's find our other minimum. So we'll do number 3 for minimum. Again, left bound needs to be to the left of that low point. So I'm going to go ahead and scroll over to where it's just a little bit to the left of that point. And then it says right bound, so I'll scroll over to the right of that point. And then guess, so I press enter. It's going to give me my other minimum value. So this value is at 1.57 and 0.87, or 0.88, let's round up. So that would be my other relative minimum in this picture. Alright, so the last thing we find there is my maximum. So let's go second, trace, maximum. And again, left bound and right bound. So I need to move my cursor to the left of that high point. Then I need to move it to the right of that high point and press enter. Press enter one more time. And my maximum has an x value of -0.32 and a y value of 12.64. Alright, so what I'm going to do now is go ahead and write those points up here, and I'm going to draw a little sketch of that graph. So that graph looks something like this. I know it's not a very good picture of it, but that's alright. So those turning points, or local mins and maxes, I had a maximum at -0.32, 12.64. I had a min at -2, 4, and I had another min at 1.57.88. So the last thing we're going to look at that graph is the places where this graph is increasing and the places where this graph is decreasing. Okay, so if your graph is increasing, basically anywhere that as your x's change and move to the right, we need to see what the y values are doing. If my y values are getting bigger and going up and up and up and up, then my graph is increasing. So from this minimum all the way up there, my graph is increasing. My graph was also increasing from this turning point until this turning point. So on those turning points, it's basically the points where your graph is no longer increasing or decreasing, where it changes. Then my graph was decreasing, those y values were getting smaller all the way over here from -infinity to that turning point, and then from my one max to my other min. So the other thing we're going to do is we're going to list the places where that graph is increasing and decreasing. And what's going to matter here, we're looking at this from left to right, so we're going to write the x values for this. Okay, so if I look at the left of my equation, this graph is decreasing. We'll do decreasing first, from -infinity until -2. That graph is also decreasing from -0.32 to 1.57. So that's the areas where this graph is decreasing. And again, those are the x values. Okay, those are the x values where my graph is decreasing. Then my graph is increasing from this turning point, which was -2, and then up until the other turning point, which was -0.32. And then it's also increasing from that point there, which we know the x value of that point is 1.57, all the way to infinity. And that's the locations where my graph is increasing. Alright, so what we're going to see more often than the regression stuff is a lot of this increasing, decreasing, and finding our mins and maxes. A lot of actually what we're going to do in class is also some word problems involving some of these mins and maximums.